Okay, hi. Let's discuss a little bit about variables, alright? So why? Well, I think before even starting with what, we're gonna start with why. Why variables? So yeah. Forget like this, alright. Great. So, like, forget about variables. Forget about anything else. Now let's say I want to count, for example, two numbers and to hold the value of the last one, alright? So as an example, we have this number 1 plus 1 equal 3. Or just kidding, I know, like it's 2. Alright, so this 1 plus 1 equals 2. How do we count it in our brain? We deeply inside of our brain, alright, hold a place for storing the number 1. And then we hold another place for storing the number 2. I mean like the second number, because this is the first number. And that is the second number, alright? And this is the result that we want to say. Alright, we're holding this value here, and we're holding this value here, and then we count it and we store it somewhere. Well, I'm sorry, my drawing is really bad, but yeah, I hope the idea is very clear. Well, and then we say the number. How this will become cleaner is that if I told you, for example, to calculate for me that number plus that number, what's the value? So now you need to memorize this number, and to memorize that number, so what means that it means that you are going to store that number somewhere in your memory, and then that number somewhere in your memory, alright, in your brain, and then you're going to process the addition between those two numbers, and then you're going to say, oh, the value is this. And you're going to store the value itself somewhere else. Like, it's very clear and very clean. Okay, nice. Okay. Now let's say again, you have something like hello, and like you have to say hello world. Like this is you want to say hello world. Alright, so this is hello and this is world, so we're gonna say hello world. So it's the same thing, alright? For example, a kid, well, memorize this word first, alright? So which means it's gonna take a place in his memory, like a variable, alright? He's gonna store it somewhere, and then he's gonna store the second one, and then he's going to say like, oh yeah, hello plus world equal hello world. Same thing, alright? So another example, alright, is when we're talking about, for example, you're taking a board and you write the first number and then you say addition to the second number. Alright, so this board is your memory. Alright, you're storing it here. This is the first variable, you're storing the second number here, and then you calculate, so in order to get like some kind of result. And then you calculate and store it again here. Alright, same thing for the computers. Alright, so as an example, a computer will calculate for us for like the computer is like a machine for doing calculations, alright? So it's doing like calculations all the time. So I hope you have heard about RAM, which is random access memory, if I still remember. Alright, RAM, which is the one who plays the role, alright, of the memory, the place where we save temporary values that we want to use. Alright, so, and the CPU is the brain, alright, or the place in the brain of the computer that does the logic and the calculations. Very clear. So let's suppose I want to create, like, let's suppose computers do not have that mechanism of variables. This is a problem, right? So I do believe that when we learn, we have to know the why first, and then we will just dive into the topic more. So yeah, now the why of that is, let's suppose there's no memory for saving temporary data in the computer. All right, so let's suppose you gave a program, for example, some sort of a number. All right, well, let's just have an example here. Like this is a so let's suppose we say math, all right, which is a program that takes, for example, this number plus this number and outputs for us the result. All right, it's pretty clean here that we have in a program called math, and then we've gave it the first number and the operation that we want to do, and then the second number. What's going to happen in the case that there's no place to hold the data that means there's no way for the computer to remember what you've typed there, so it can't calculate it. I hope it's very clear. So this number plus this number, so this number should be stored somewhere in the memory of the computer, the first one, like which is that number, this number, all right, has to be stored somewhere in the memory of the computer, all right, and then this number too has to be stored somewhere in the memory of the computer, and then we do the summation, all right, and the same thing for the result, all right. This result itself has to be in somewhere in the memory, so the memory can remember it and then print it to us. Now we know the why variables are very important to have them. All right, perfect. Yeah, I hope like. So what is a variable? No, let's just have this one like this. What is a variable? Okay. Okay. Introduction to variables is named storage for. All right, we've explained that a variable is just a place that you hold in the memory for storing some data. All right, so you can think of it like this. All right, this is the memory of the computer. We're gonna think of it like that. This is the memory. All right, so it has some places, all right, like this, some boxes, all right. Each box has an address. All right, I'm sorry for my bad drawing, but yeah, address, all right. Each place has an address, a specific address. For example, this one has address 01. This one, for example, has address 02. This one too has some sort of address like, oh yeah, 03. All right, so and it has some data inside of it like 0, for example, or 10 or 11. All right, so if I told you like this address, which is, it has address 01, and we name it, for example, first number, it's just, suppose we name it this variable, we name it fn, and this one we name it, for example, sn, and then this one again we name it rn, which means result. All right, let's just name it r. So we have 0 plus 10. All right, so we're gonna hold 0, and then we do the operation with it, like we hold 10, and then we sum them, we do the summation, and then we put it here in the third variable, and then we take this third variable and then we print it. Let's take a problem now. Now we want to build a program that takes two numbers and prints the result. All right, so let's take as an example, I want problem, create a C program that prints the summation of two numbers. All right, so it's very clear that this is the problem that we have. and we're gonna solve that problem using variables, because we need variables for saving the values, and then then printing them, all right, or doing anything with them. So that is the meaning of variables. Like, it's very clear now. All right, declaring initialization of the variables. All right, now let's take that one and touch, and then we're gonna have like we're gonna create like a C program, and then we're gonna get here and include. All right, you see the io.h like this. We're gonna include the library that we always include, so we can print to the standard output. All right, we can use the utilities like printf and scanf and the other utilities that we're using in order to deal with the input and the output. So now we're gonna create the main function. All right, so this is the main function. This is the return type, this is the main function. All right, this is the name, and that is the place where we put again the arguments for the function, and this is the return type of the function. All right, so perfect. Now we want to create a program that gets two numbers. All right, so now we're gonna see how we declare a variable first. See, like here, this is the way we do it. We have like something like int, all right, x. This means the type of the variable. So this is the way we define it. The structure for defining a variable is this. We take the type of the variable and then name of variable, and then semicolon, which means the end of the instruction. Perfect. So why we have the type of the variable and why we do have the name of the variable? Very clear again. So sometimes the data we're holding or the data we're dealing with, maybe it's a floating point number like 1 point this, or it is like a natural number like 1, 2, 3, 4, 5, etc. Or where it's maybe something like a text, all right, hello world, or other types, all right. So the type of the, like, you're not gonna take, for example, a variable, a place in your memory that is meant to store, for example, like text, and you're storing inside it, for example, a number. The way your brain is processing that place, focus with me in that, the way the brain processes that place is gonna always that it thinks of it as a string. I'm gonna find characters there, not numbers. So this is a very good idea that we will need later on, but just think of it like this. A variable tend to have like some kind of data, and this data may be integer, maybe float, and maybe like other data types. All right, that's perfect. Why the name of the variable now? The name of the variable is, you can think of it as the, like, let's suppose you've defined a variable, but it has new name, all right? How you're going to access that variable later on? You've got what I mean. Like, let's suppose I've saved like some data somewhere in my memory. I do not really know exactly the address and the place for that data. I'm gonna lose it, all right? I'm not gonna be able to access it later on. It's that simple, all right? That's perfect. All right. And then we're having a semicolon, which means the end of the instruction in a program, because our programs are a bunch of instructions. Do that, do that, do that, do that. Each instruction ends with a semicolon. Perfect. That's perfect. Now, I guess that's enough. This is the syntax for declaring a variable. Well, but now sometimes you're declaring a variable, it's gonna take a place in the memory, all right? but this place in memory has been used by another program before. Alright? Like in this example, let's suppose this is our program has used this memory, and now our program has ended up. Another program came on. He's gonna try to use that memory. Alright? He's gonna find junk data there, which may cause problems in that program if he didn't if that program didn't override the data and make sure like that the data inside of the variables are meaningful. That's why there's something called initialization. So let's suppose you're doing summation. All right, you're doing summation of 10 variables, and you've created like a variable named sum. All right, and that variable, which is named sum, has to start with the value 0, but you didn't assign it with anything. Let's suppose you've created that way. You've said like int sum, and just you've left it like that. All right, so this will create like a variable in the memory. All right, so it's gonna go to the memory, create for us like a variable named sum, and but that place in the memory has been used, for example, by another program, and it has left, for example, some value like -10. All right, so let's suppose you've came and you started calculating after this instruction. All right, you've just added some stuff here. Let's suppose the first variable that we want to add to the sum its value is 5, for example. All right, so the data that the sum is gonna have is wrong because we didn't assign it with the correct value. So that's why there's something called assignment, which is the starting point value for the variable. All right, so it's like this. Int sum. All right, this is the creation of the variable, and then sum equal 10. This is giving the variable a value. All right, but if we've done something like this, it is the same as the previous one, but we've blend them together, and this one called initialization. All right, you're starting like this variable with the value of 10. Initiate, yeah, you're initiating this variable with the value of 10. Perfect. So, but always the sum or the average or those stuff start with 0. All right, so that's why we're gonna have it like this. Perfect, perfect. Well, the difference between, we've talked about the difference between declaration and initialization. We said that the declaration is just defining a variable. It may contain any arbitrary data. We do not really control it. And the initialization is the data that, and the initialization is making sure that the variable started with a specific data. All right, perfect. Well, now we're having the data types. All right, we've talked that a variable will have a specific data type. It may be int, it may be integer, it may be float, it may be integer, it may be float, it may be character, it may be double, etc., etc. So, integer, for example, is the wide and most known data type that we almost use all the time. It holds numbers, all right, like 1, -1, all right, etc. Well, my laptop is gonna turn off. Okay, perfect. All right, it may be 1, -1, -2, etc. -2, like -10. All right, and then 10, but it has no floating point numbers. If I still remember this one, we've learned it in maths, and so we can think of integer as a data type that holds the numbers that belongs to, I guess we've named it Z, but I don't know, I'm not sure if like everybody uses that symbol, but I guess we've used that. I guess that's what we use here. But you know, yes, it's this. So we can make sure that we all think the same way. -1, and then 0, 1, and then 2, and then until plus infinity. All right, and then minus infinity. Well, perfect. This is integer. All right, and there is also int as a data type that holds, and there's also long, which long that holds the same data type, but it has a wider range, because this type actually does not hold plus infinity variables. I mean, like, just the data type is the same, but there will be limits, because we said that a memory, for example, like when you define a variable, for example, in the memory, it will take some like some places like this. All right, it will take like a specific number of bytes. All right, I hope you have like an overview about bytes. Byte is like 10 bits. All right, a byte is 8 bits. All right, so of course it's not going to be able to hold like infinity, because it's not infinite. All right, it has a finite size. So there will be a maximum value, all right, here, and a minimum value here. And there will be a maximum value for long here. There will be something long. And then the same thing, there is another long data type named long, which hold the same data type, but the size of the variable is different and is bigger than both of those. So because sometimes you want just to save like numbers from 1 to maybe 6 million, 7 million, so you're just going to use something like integer. But sometimes you want to count, for example, billions. Maybe you may use long or long. So it just depends on the use case. So we try to save the memory by minimizing the size of the number, the size of the data type that we're holding in the memory. All right. There is also another one called char, which is smaller than this one. If you want just to save a few thousand, maybe you're just dealing in 1,000 numbers. You're not dealing with millions or whatsoever. Perfect. So we've talked about integer. We've talked about long. All right. There's something called long too, as we said. There's something called long. All right. I don't really. Yeah. All right. That's it. Float. All right. Float is the data type that holds, for example, floating point numbers like 1.2. All right, or 1.3. All right. I said my drawing is very bad. 1.3. Whatsoever. You know, you can think of it like this. Well, and then we have char, which is an abbreviation for character. All right, something like if you're going to store like some character like C, A. All right. Sometimes, for example, a program asks you to press like N or Y. So the variable that are going to store like this, your answer is just a character, a variable of type character. And this one has just the size of 1 byte, all right, which means 8 bits. And then we have double, which is the same as the floating point, all right, which is the same as this one, except that it is wider. If you're going to calculate some precise number, all right, some like bigger number with more floating point numbers, yes, it's maybe useful. Yeah, so you may use like double instead of float, but the widely used one is float. All right, that's it. So, but both of them are storing the same data. Now let's talk a little bit about some keywords named signed and unsigned. All right. So signed, it means that this number can hold positive and negative values. All right. And unsigned means that we explicitly tell the computer that this number always will store like just positive values. Like as an example, if we came here, and we said that age is an example, we want to create a variable named age. Of course, there's nobody who his or she's age is -1, all right, or -2. So That's why we're going to proceed like int age with something called unsigned. Alright? And this means that we are going to explicitly hold only positive values, and this number won't hold negative values. And what is the benefit of that? Is that the variable is going to be wider, is going to be able to hold more values. All right, because let's suppose we're taking unsigned. If the variable is signed and unsigned, we take the same number of bytes. So we're taking, for example, n bytes. All right. All right, we're taking n bytes. Wait, let me type it here. If the number is signed, which means int only, or long only, therefore the number is signed. 1 if the size of bits that this number holds in the memory is n. 1 bit is gonna be used for the sign. I hope it's clear. Like alright, so we're gonna do that and represent it a little bit. Let's suppose we're going to represent some number here. I hope you have a background in binary. So this byte here is going to be used for sign. Oh, this number is going to be used for the sign. This bit here is going to be used for the sign. If the sign is 0, that means it's positive. If the sign is 1, that means it's negative. Alright? So if here is 0, means positive. If it's 1, means negative. So, and those are the ones where we represent the real number itself. Alright? But if the number is unsigned, we're using the whole all of that as a number, including this one. There's no sign anymore. So this one will just go. And we're gonna use all of this one as a number. That means that this number with the same size is gonna be able to hold like a larger values. If we're sure that the value or the number, if we are pretty sure that the number won't need or won't hold like negative values, it's just better to make it unsigned. Alright? Perfect. I hope this is clear. If it's not clear, just write in comments what's not clear and I'm trying to make it cleaner. And another thing I would just to talk about, if the style of like explaining is really bad or there's some kind of point or whatsoever, just say what's not bad there, what's bad there, and I'll try to make it better. Thank you so much. I appreciate it. So, how they affect memory and behavior, alright? We've talked about that signed, alright? We've talked that there's a difference between the data type that the variables, the different data types hold, etc., etc. And we've talked about long, we've talked about unsigned, etc. Perfect. And I guess this is perfect. Until now, I guess this is very enough for the moment. In the upcoming video, I'm gonna try to talk about we're gonna solve a little bit problems with the variables. We're gonna solve a little bit of the problems with the variables, and I'm gonna try to explain like some stuff, you know, like scope and lifetime of the variables and constants. All right, sometimes you do not want to change the pi. All right, we all know 1.14. I still remember. All right, we do not want to change that. Oh, it's 3. I do not really remember the value of pi, but you know, we do not want to change it. All right, sometimes we do the calculations with it and we don't want to change it. So thank you so much. Take care. Thank you.